Hello, welcome to this video. So in this video session, we will be discussing about spying. Actually, in the Mockito, when we write any mocking implementations, when we are testing that dummy implementations are to be considered. Suppose if there is a scenario that say I want to directly check on the actual implementation of my class. So in that case, we can make use of a concept called spying. So spying in Mockito allows us to execute the actual method of implementation. So without affecting it, right? It will create a new set of spy object, and on that object, it will try to implement your method. Now let us see how to implement this with a small example. Observe here, I have an interface called calculations with two methods. So one is calculate square area, another one is calculate rectangle area, and it is taking some inputs and returning the integer value. And I have my implementation class for that method. So I have implemented that calculations in this class. So I simply just returned some value for this method. For the calculate square area, I have returned a value of 100, and for the calculate rectangle, I have returned a 200 for our demo purpose. So actually in your real-time experiences, say in the real-time requirement, so whatever the functionality that you want, you can write and that return value can be returned. So I have one implementation class here. In my test class, right, I want to test it. Let us assume I don't have this implementation, right? So in those cases, so actually our Mockito will come into rescue. Right. Say what we are doing as per our previous examples. Say when we don't have, right, when we don't have the implementations, we will actually mock the behavior. So how can we mock the behavior? By using when and then return methods, right? Now if you see in my test method, I have called this, I have created one mock object for calculate. Say instead of this, I have to write the calculations, right? So calculations. So on that object, I have called this method calculate square area. So whenever you call this method by passing some value, return the value as 10. So now I am asset equals, calling the asset equals method, right? So suppose if I make use of this one, say asset equals calculate square area of 10 comma 10. So obviously this test will be passed, so that this behavior, right, this behavior will taken into consideration. Suppose I have my implementation. See, I have an implementation class here. So in this class, actually, when you call this method, it is returning 100. So I want to make use of this definition. So in this example, so in order to make use of that, first what we need to do is we need to create one spy object. So this spy object is a temporary object created for any defined class. So for every method, right, when I want to make use of this, it has to be created. So to do that, any task before any method, any test method, so we have a test annotation known as @before. So this @before will perform the activity before every method, right? This is the JUnit framework's functionality annotation here. So in this, I am calling a method called spy method. So you need to pass the actual implementation class which you want to spy, that as a parameter to this spy, and it will return its reference, right? So now I have called this spy method by passing the actual implementation class, that is your calculate area impl class, and it returns anyhow the parent type. I can catch the parent type, so calls method. So in this case, I don't write this when, right? I don't want to use this when. So it has to actually calculate and then that value must be returned here. So now in this example, if you look at here, I am calculating, I am calling this assert equals calculate service area. So it won't take this. I have commented this. It will directly go to the actual implementation, and in this implementation 100 is returned. So that 100 will be returned here, right? That 100 will be returned here, and in this case it will compare with the expected value as 10. So obviously our test will be failed. Suppose when I give here as 100, right? When I give here as 100, and then when I run this one, now my test method is passed. See, because I am spying on the actual implementation. So this actual implementation is returning 100. So when it is returning the 100, so it is also comparing with the 100. So that means whenever you want to implement your test on the actual methods reference, then we have to go for spy. So let us observe there is a case I have actual implementation and also a mocking method is there, right, by using when. So in this type of scenarios, your local definition will be having higher precedence. It will be overridden. So that means it will not, in this scenario, now you have the spied on the class, but at the same time you have the when method, Mockito when method is also there. So in this scenario, it will have the local Mockito when methods preference rather than the actual. So in this case, what it will do, it will try to return the current value, that is the 10. So it will compare with this 10 and 100 and makes that method as false. Suppose when I give here 10, then this method will have the passed, right? This method will be passed. See, because local definition has the higher precedence, right? So in this session, we have discussed about how to call the actual methods spying implementation, and whenever you have both spy class implementation and the Mockito when method implementation, when will be having higher precedence than the mocking object, than the spying object, right? So this is a simple example which demonstrates this concept. That's all for this one. We'll meet you in the next video.